Hey, it's Wednesday, April 1st, 2020. Done been got. I made this video once already and said it's gonna be a super long one. Haha, just kidding, April Fools. But it seems I'm the one who's been fooled. Because the first time that I recorded this, it did not record with audio. So guess who's back for round two? Mr. Howard, yay! Alright, so here we go. Take two, roots and zeros. So we've kind of already talked about this, but zeros are the same as roots, which are the same as x-intercepts. We're looking at where the function crosses the x-axis. Okay, zeros, roots, and x-intercepts all the same. We can see that those are all the same if we set up and find the zeros by saying p of x is equal to x squared plus 3x minus 18. Our zeros here are negative 6 and 3. That's where it would cross our x-axis. Okay, our roots here of x squared plus 3x minus 18, remember that's the same function, equal to 0, are still negative 6 and 3. If we would solve those and break them down into two binomials, it would still be negative 6 and 3. The factors of x squared plus 3x minus 18 are x plus 6 and x minus 3. Remember, that's what multiplies to get negative 18 and adds to get positive 3. It would break down to be these. If we set these up to equal to 0, we would see that x equals negative 6 and 3. Okay, so these are all the same so far. And lastly, the x-intercepts of p of x equaling x squared plus 3x minus 18 is where x is negative 6 and the y value is 0 because we're talking about x-intercepts. So we have to have that y value for an x-intercept. And x is 3 and y is 0. Okay, so all three of these things, even the factors, kind of mean the same thing. So these three words can be used interchangeably. The number of roots that a function might have depends on its highest degree. Okay, so if we were looking at this first one, the highest degree, we have a 0th degree, a 1st degree, and a 3rd degree. So that means that our highest degree would be 3 on this first one. We have a 0th degree, a 3rd degree, and a 4th degree. So the highest degree is 4. And this last one, we have a 0th, a 2nd, a 3rd, and a 5th. So our highest degree on the last one is 5. Okay, so the number of roots that we have on this first one is 3. The number of roots we have in this function is 4. And the number of roots we have in this function is 5. Okay, roots, remember, meaning where we're crossing the x-axis. All right, and the last thing we want to talk about is multiplicity. And this is the number of times a number is a 0. So a number can be a 0, but the multiplicity asks how many times is it a 0. So if we had the function f of x equals x cubed, clearly we can see that x cubed, if we wanted to find its roots, if we wanted to find its zeros, we could set this up equal to 0. We could take the cubed root of both sides and see that x equals 0. But multiplicity asks how many times, what is the number of times that the number is a 0? So x does equal 0, but how many times does it equal 0? It equals 0 several times. We can see that by saying that x to the 3rd is the same as what? X times x times x, right? So I can essentially rewrite this as x times x times x. Okay, that means that I can set each of these factors up equaling to 0. So I can say x equals 0, x equals 0, and x equals 0. So really our answer is x equals 0. We don't have to write it 3 times. But the multiplicity says what is the number of times a number is a 0. Not necessarily the number 0, but that it is a 0, meaning that it crosses the x-axis. Okay, so the number of times that x cubed is a 0 is 3 times. 1, 2, 3. So the multiplicity of x cubed is 3. Okay, and that is it for our lesson today. It's a little quick one. Thought I'd give you a short one for April Fools. So go out there and try and get somebody good. I've already been got, and it's a week before then. So hip hip hooray for Mr. Howard. See ya. No exit ticket today either. Just hit submit on your Google Classroom. Bye. Adios.